Okay, it is 9:45, so I think we will get started. I'm just going to introduce Miguel really quickly. Miguel and I are chairs of this session, and Laura is moderating and taking notes, as well as I see Kaylin in there from the Harvard Library, which I appreciate. Most of you already know me. I am Sonia Barboza. I manage curation for the Harvard Dataverse and work with the development team at IQSS. And Miguel is going to introduce himself as a representative of IBECT and runs the Cariniana installation in Brasilia. So Miguel, take it away. It's all yours.
Okay, thank you very much, Sonia. Good morning, everybody. I'm very happy to be here this morning. As Sonia mentioned, I'm coordinator of the Brazilian Digital Preservation Service Network at IBICT in Brasilia City. I'm so excited to be hosting this section today with the support of the Dataverse Project team. I don't know, before we get to the presentations, I don't know if I can do the quick introductions. Or can I start the introduction? Okay, so I'm going to share my screen. Thank you. Yeah. Okay. So please tell me if it's okay for you, as I have some problems with my computer at home, but I guess it's okay. Well, so everybody here knows what a digital object and what digital information is. It's something that you all know about that. It's something that we can describe as data encoded as a series of zeros and ones, or stored on magnetic or optical media, requires specialized hardware to read, specialized software to operate, application to interpret it or render into usable form, and also the contextual knowledge. And also, everybody knows too that the digital preservation also involves very different tasks. Digital preservation is this series of strategies and actions taken to promote the availability and usability of digital information over time. And also we have the need to understand what means long-term period of long enough to raise concern about the effect of changing technologies, including support for new media and data formats, and of a changing user community. These are some descriptions of what we are talking today. But in the case of the term of digital preservation in the long term, it also implies that we want to require management of information over generation of changing in technology, user expectation, staffing, economic conditions. And also there are many ways of describing how do we apply the preservation techniques for digital collections. One of those that will always be present and we mentioned today is the planning of digital preservation. Digital preservation planning will help us to define basically two things: what the repository requirements are and policies of access, privacy and reuse, curation services that will help to organize data for preservation, and what the data curation center says of the curation life cycle, undertake actions to ensure long-term preservation and retention of the authoritative nature of data. They are actions that can be taken to mitigate the technical challenge of digital over time. So the digital preservation action promotes actions to ensure this long-term preservation and retention of official data. Preservation action must ensure that the data remains authentic, reliable, and usable while maintaining its integrity. We know too that digital preservation of data means that the correct implementation of OAIS model with adequate digital curation and making use of appropriate and adapted metadata for the new scenario. In 2006, on the Dataverse Project, when the Dataverse Project started the preservation functionality was already present in the software structure. It was very important for us to realize that the preservation functionality was important for the project. Some preservation action continued in the next years, with continue to be mentioned among the project best practices, like the preservation format conversion, the checksums for other files. And as well as something that is very important for us is as the need of the integration with preservation systems and the definition of preservable files formats. And in 2015, also we realized that the Dataverse Project have a very important promotion of the preservation policies on the world, talking about the Harvard Dataverse Preservation Policy. That version on 2015 has specified that digital objects will be managed to ensure that they are not altered and that they are original data that is preserved. And that is very important for us. And also because in the last year, the new version of the preservation policy include the new storage services and continue to reinforce the distributed preservation in the Data Preservation Alliance of the Social Science, called Dataverse. So now, and this year, we are here and we are talking.
Sorry, Miguel.
Yes, sorry.
1 minute left.
Oh, yes, I'm finishing almost. And this year, it has been mentioned that one of the strategic goals of the Dataverse project is to expand archival and preservation features. For those of us who are still interested in following the development of Dataverse preservation functionalities, it will be great to know what will come beyond the version 5.5. As, for example, the common framework for preserved file formats, integration with other preservation systems, service that could help organize data for preservation processing, or a research data distributed digital preservation network, maybe. And finally, I think as a community, we need a shared understanding about what comprises the digital preservation, articulating the main technical and sociocultural problems, identifying impediments and barriers, including limitation of resources, and developing a gradual action agenda in our institutions. So we know that we can do that, and I hope this is going to be a very good session today. So I pass the word for Sonia, I guess. Thank you.
Thank you very much, Miguel. That was a great introduction. We're going to start our talks today with Preservation Pathway for Research Data at Harvard Library by Kaylin Boyd and Tricia Patterson.
Okay, great. Thank you very much, Sonia. And I'm going to turn off my, video just to save bandwidth here. So I'm Kaylin Boyd, and Tricia Patterson and I will be presenting on preservation pathways for research data at Harvard Library. A little bit about Harvard Library, you may know this. We're an umbrella organization for all of Harvard's libraries, archives, and shared services. This is a highly decentralized organization. It includes about 70 libraries and archives that support 11 schools and many institutes. So you can get a sense there about the number of stakeholders that we have, the number of different file formats, different interest groups, different kinds of data, and different kinds of content that those groups may produce. In this slide, Tricia will give us a little bit of background about what digital preservation is for Harvard. Take it away.
Yes,
Tricia.
Thank you, Kaylin. So I'm a senior digital preservation specialist at Harvard Library, and I wanted to talk a little bit about, we're going to discuss kind of how we're starting to think about integrating some of our data digital preservation repositories, but I wanted to kind of set the stage for how we conceptualize digital preservation at Harvard Library. And as Miguel outlined in his really excellent introduction, we think about digital preservation as being less about maintaining digital objects indefinitely and more about facilitating meaningful communication with the future. So we're bringing together people and policies, procedures, and utilizing technology to ensure that ongoing core functionality of an object. So just as an example to highlight these core functional qualities, take preserving email as an historical object. You'd want to make sure, integrity, is it a stable digital object? Making sure the email file itself doesn't degrade or isn't lost. Authenticity, is the email legitimately received by the purported sender to the purported recipient, or was it phishing or spoofing? And if it was phishing or spoofing, perhaps we want to maintain that for future historians to be able to conduct research on that kind of email phenomena. Accessibility, can you retrieve the email file decades or centuries from now? And usability, which is kind of the most important or a really important aspect here, which is, can you open, read, and interact with that email object in a way that conveys a meaningful experience? And you need to be able to define what that meaningful experience is going to be. Is it enough to just open it in a text editor and be able to read the content? Is it important to preserve formatting and inline embedded images? Will it be important for future researchers to engage with the email platform itself? Do we want to preserve the email software application and the operating system that supports that software so that we can recreate that information experience? And we can move to the next slide. Our digital preservation repository at Harvard Library has been in production for over 2 decades now. We haven't lost a bit yet. We have over 10 million objects or intellectual works, for instance, a audio file or a book. And those are comprised of over 110 million files. And all the content in our repository is currently replicated 4 times across different storage architectures, eliminating single points of failure, like relying on one kind of storage media, and storage locations are geographically distributed to additionally eliminate single points of geographic failure. So if there's an earthquake in one area and all your storage is focused there, that's an elevated risk. We run fixity checks across all our content at regular intervals to ensure that no files are degrading or getting lost or being altered by anyone inappropriately. And then, as you can see here, files come to us in a variety of formats. We have over 60 formats, but then many different flavors of those formats. So TIFF, TIFF versions 4, 5, 7, 8.5, TIFF XF, TIFF baseline by level. And the way that our repository works, it currently accepts kind of a rigid content model. So really specific formats for specific intellectual objects, which, as we'll discuss, can be a barrier to large scale depositing of data. But the real reason that we've historically operated that way is because it helps us identify how to actively manage that content over time. Just a quick example is that we have a bunch of old audio content, and it used to be deposited as real audio files. And as those became increasingly obsolete, we were able to strategize a large scale format migration to more modern preservation friendly formats. Go to the next slide. I'll hand it back over to Kaylin to talk about our different infrastructures at Harvard.
Thanks, Tricia. So the DRS that Tricia talked about is one of the 3 digital preservation infrastructures that we have at Harvard. You're obviously all familiar with the Harvard Dataverse installation, but we also have this open access institutional repository called DASH, which is where faculty, students, staff, and other Harvard affiliates can deposit their research outputs. And that could be preprints or journal articles or conference papers, dissertation theses, and so forth. So that's what we call DASH. So these are our 3 preservation infrastructures. And one of the things that we're trying to do is get these infrastructures to talk together and to have some integrated workflows. On this slide, you'll see that these are some of the preservation research and digital preservation workflows that use the 3 preservation infrastructures. The infrastructures there are shown in blue, and you'll notice that based on the arrows that there aren't really any of these formal paths between them. That's what we're working to change with a series of conversations that we're having around systems integration that I'll show you in the next slide. So this slide gives you an idea of what these kinds of 3 sets of conversations that we're having about kind of focus on. So let me address them individually. First, there's this obvious pathway between Harvard Dataverse and DASH, our institutional repository. What we're trying to do there is link DASH articles to related data sets using the bidirectional functionality in Harvard Dataverse, but also create more topical collections around subjects like, say, COVID COVID data. So right now on the Harvard Dataverse installation, you see that we have a featured collection of COVID data that we are working to connect up with the kinds of articles that are in DASH already to link those scholarships together. The next pathway is our DASH and DRS pathway. And in that particular case, we're working to push DASH content into DRS in quarterly batches and investigating the cost implications for that, because DRS has a different kind of cost model and different kind of stewardship model than we might be familiar with it. And so these things aren't necessarily always compatible. So we have to figure out kind of the question, who pays in that case? In addition, there are these issues around the specific file formats. So one thing that we're working to do is investigate what it would take to support these additional file formats or content models, such as HTML. And then finally, the topic that you're probably all interested in is, well, what does the pathway between Harvard Dataverse and DRS look like? In this case, we're taking a look at what kinds of content model would support research data. Right? What would that look like? Because we know that research data is very complicated. It might include software, it includes all different kinds of supplementary materials. So what would that content model look like? We're looking at ways to package and push selected data sets from Harvard Dataverse, so an appraisal method, into DRS. And then we're also looking in the opposite direction. We obviously in DRS, we have a tremendous amount of content there, digitized collections and so forth. What would it take to move things out of DRS and store them in Harvard Dataverse as library collections as data? So on this slide, this kind of summarizes some of the considerations that we are having around these conversations. Tricia, you can speak to DRS and then I'll jump in with Harvard Dataverse.
Yeah, so some of what we're working on to better accommodate these pathways with the DRS is we need to be able to scale deposits better. We need to be able to accommodate that. So that goes for size. And as Kaylin pointed out, it goes for formats to enable more people to actually.
Sorry, Tricia, 1 minute left, okay?
Okay.
No problem.
Yeah, so we're building more flexibility into our repository. And similarly, our repository is really library facing right now. It's not optimized for bringing in content from researchers, and that's a critical, mission for us. But once we start opening the floodgates for all this new and varied content, we really need to focus on how to strategize for long-term usability of that data, not just the stability of it. Go ahead, Caitlin.
Okay, so on the Harvard Dataverse side, we have a challenge with the different models, right? We have a self-deposit model. We also have these managed collections, which brings up issues pertaining to stewardship, appraisal, preservation funding. Who pays in those particular cases? We obviously have the variety of file formats, but then there's also this issue of data set versioning. Which is the canonical version, the one in the DRS or the one in Harvard Dataverse? And how do we make sure that those versions are kept up to date? And then finally, there's the issue around preservation monitoring. Which collections do we monitor? Which file formats do we monitor so that we can actually do migration moving forward on the particular collections that we've determined should be marked for deposit into DRS? And that's it. So thank you very much. Please let us know if you have questions.
Thank you very much. As I was just posting that, even I enjoy your presentations because I get a little bit of new information every time. So I like to see these collaborations. Thank you. We're going to do questions at the end just to save time. So our next speaker is going to be Grant Hurley. He's a digital preservation librarian at Scholars Portal, and he's going to be talking about APIing research data, integrating Dataverse and Archimedica.
All right, thank you so much. I'm just gonna share.
You're welcome, thank you.
My slides. I really appreciate Sonia and Miguel for inviting me to give a presentation today. It's great to be part of this meeting. So as Sonia mentioned, I'm Grant Hurley. I'm the digital preservation librarian at Scholars Portal. I'll tell you what Scholars Portal is in a minute. First, I'd like to begin by acknowledging the land that I'm speaking from. That's the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. And it's home to many diverse First Nations, Inuit, and Métis peoples. The city of Toronto is covered by Treaty 13, signed with the Mississaugas of the Credit, and the Williams Treaty, signed with multiple Mississaugas and Chippewa bands. And I'm very grateful to pursue my life and livelihood on these lands, where I've lived for 6 years. And I originally hail from unceded Passamaquoddy territory on the shores of the Bay of Fundy in the province now known as New Brunswick in Canada. So this is a quick outline of what I'll be talking about. Integration between Dataverse and Archimedica, a project that we undertook at Scholars Portal with staff at Artifactual Systems a couple years ago now. And then I'll talk about some developments that have happened since then. So Scholars Portal is the information technology service provider for OCUL, the Ontario Council of University Libraries, which is a consortium of 21 academic libraries in Ontario, Canada. We were established in 2002 as a way of implementing OCUL's planning and direction, and we're formerly a unit of the University of Toronto Libraries, but we serve out digital services of many kinds to our 21 members across the province, and now beyond, in fact. And our role really is to help our members meet the needs of their students, faculty, researchers, and other stakeholders in the provision of shared technology services, of which digital preservation services is a key part. And that is what I'm responsible for there. In the context of Dataverse, we've been supporting Dataverse at Scholars Portal since 2012, but more focused development really started in 2015, specifically for OCUL members to deposit research data. The Dataverse installation was expanded to the Quebec Library Consortium in 2019, and it's expanded considerably since then. Scholars Portal's Dataverse instance is now national in scale. We have 59 institutions across Canada using it. And we're connected up with the Portage network, which you may have heard about in other sessions, a national research data management support network, via a Dataverse North advisory group. And then, of course, we share lots of Dataverse supporting staff who are part of our community with Portage expert groups. Basically, it's all the same people and all the same calls. And recently, there was a new consortium organized to essentially organize national governance of the Dataverse service beyond the OCUL sort of context in which it was initiated. So a few years ago, we were looking into how to connect Dataverse and Archimedica for preservation, motivated really to connect the two to enable functional workflows for preservation between the two systems. So OCUL sponsored an integration project with Artifactual Systems, who supports Archimedica, first in 2015 through a proof of concept project, and then in 2018, where the results of that project were rolled into a public release of Archimedica. So as of Archimedica 1.8, plus some fixes that happen in Archimedica version 1.9, you can pull data sets from Dataverse out and then ingest them into an Archimedica preservation pipeline. I've mentioned Archimedica a couple times now. You may not be familiar with what it is. It's an open source standards-based workflow tool for processing digital objects for preservation and access. It's configurable such that it will generate and verify checksums, perform file format identification, characterization, and validation, and also run optional normalization functions for both preservation and access purposes, and much more. There's plenty that goes on in an Archimedica workflow, but its main goal really is to generate standards-based, well-formed archival information packages for preservation storage and dissemination information packages for access purposes. So when we designed and worked with Artifactual folks to create this integration, there were a few assumptions that we started with. One is that the person doing the preservation, performing preservation actions, has a Dataverse account and an API token. So they essentially have some admin access to a Dataverse instance. They also have access to an Archimedica instance installed somewhere. And that could be through a hosted service. It could be installed locally. It can even be just running on your own computer if you like. You obviously have to have necessary rights and privileges to process and store data sets independently from Dataverse. It's a key consideration. And of course, the preserver is interested in selecting and processing specific data sets in the target Dataverse instance for preservation. This workflow is very much based on the idea that not all data sets in a Dataverse instance might be suitable for independent preservation. Other assumptions that we made is that one Dataverse data set equals one archival package. So there's a one-to-one relationship there. and that the access copy generally is going to be the version that's still available in that Dataverse instance, which is the one that most people are going to be accessing and using. However, you can choose to create a new access copy in Archimedica. And there are some ways perhaps that further developments could make use of that access copy. The workflow is simplified as such. So through Archimedica, you can query the Dataverse instance. It's connected through the storage service backend through an API key. Select and retrieve that data set through the data access API, ingest and process it in Archimedica, and then transfer it to storage. This is some of the functionality that is actually happening during processing. So the Dataverse Access API retrieves that package, which includes original user submitted data files, dataset related metadata, including the dataset.json file, any Dataverse created derivatives of tabular files, and citation metadata if applicable. Archimedica then creates a Dataverse METS file for the original package, which describes essentially what was there when it was received. It can verify Dataverse checksums, which is great. So it sort of has that chain of integrity from Dataverse through to Archimedica. Similarly, any tabular generation that Dataverse performed is also recorded as a premise event with Dataverse linked as the agent. So you get that nice provenance metadata. And then it runs other Archimedica standard microservices as you've configured them. At the end, it also creates an Archimedica METS file, which includes dataset descriptive metadata in DDI format, a selection of fields. It outlines relationships between the originals, the metadata files, derivatives, and any actions undertaken through processing steps. But I'm going to just do a quick demo so you can actually see what this all looks like. I'll just stop my share for a second and then reshare the tab with Archimedica. Hopefully you can see this is an Archimedica instance that we host. The way it works is that you select Dataverse as the transfer type, and we have a test demo Dataverse that's connected to this Archimedica instance with 4 data sets in that Dataverse. So I can select one of them. This is just one with a CSV file in it. Give the transfer a name, click start, and that will pull that data set from the connected Dataverse instance into the Archimedica workflow and begin its processing steps. We can make this test instance available to folks if they want to try it out themselves. We just need a stable IP address that we can open it up to. So I can give you some instructions on how to do that in the chat afterward. It's been a couple of years, as I mentioned, since this integration was developed, and we're kind of looking ahead to what might happen next. So one sort of major issue is that there's some unresolved bugs with Dataverse METS file creation that are documented in the Archimedica issues repository. These do need resolution. They're not serious, but would be helpful to have them fixed. And so at some point, development needs to be prioritized there.
Sorry, Grant, 1 minute left.
Perfect. Take up has been slow. Many institutions haven't really prioritized data set preservation or Dataverse preservation as a target for resources and staffing. They haven't delineated responsibilities for research data preservation within their organizations. And they need policies for collections development, digital preservation policies, and procedures for curation and selection as well to actually make effective use of a tool like this. The good news is that this Core Trust Seal certification cohort via the Portage Project in Canada is really pushing forward policy and procedure creation and documentation, both at Scholars Portal and at our member institutions. And the Portage Preservation Expert Group just released a preservation for Dataverse in Canada report, which outlines a 2-tier approach for Dataverse preservation at Scholars Portal, including sort of preservation in place with essentially bit level preservation for all Dataverse data, and then a second level approach using the Archimedica integration through the provision of consortial hosted Archimedica services in Canada. So I'd encourage you to take a look at that report. I can put a link in the chat afterward. Other improvements that we've identified would include messaging back to Dataverse, automation, of course, either from Dataverse, like a push to preservation button, much like they use in DONS, I believe, although not connected to Archimedica. Possibly as well for groups of data sets that you could point Archimedica to an entire Dataverse, let's say, and process everything in it. Other approaches too, using the DIP or using Archimedica's new very cool ape scan tool for cross-ape reporting. These are some additional resources as well, again, that are linked here, including a paper we gave at IPRES on integration that describes a lot more of the technical details. And I must thank everyone who assisted in this project, including OCL for funding it and Artifactual Systems for developing it. So I'll stop there, but thank you very much for the opportunity to speak today, and happy to answer any questions afterward.
Thank you, Grant. And I'm going to apologize for mispronouncing, because I was having a conversation with Kaylin. I said, is it pronounced aping? Because what I saw was API. I saw AIP, my dyslexia kicked in and I saw API, aping. No. So thank you. I will never forget that again. And I'm sure we'll have lots of questions for you at the end of the session. We have lots of people here very interested in that integration. So and see, Nick Weber said too, he said he thought it was API, aping. We won't forget that. Thank you.
Thanks.
Our next speaker is Rondinelli Sad from Cielo Network Brazil. He is going to actually be presenting a use case for Dataverse and Archimedica. So Rondinelli, whenever you are ready, you can go ahead and start sharing your screen.
Let me share my screen, just a second. Can you see my screen, Sonia?
Yes, you are all set.
Okay. Hi, thank you for inviting me for this event. As Sonia says, my name is Rondinelli, and my presentation will be about preserving Dataverse using Archimedica. I am the coordinator of infrastructure and digital preservation at Cielo Brazil project. And Cielo Brazil, Cielo is a non-profit electronic library with a collection of Brazilian scientific journals. The Cielo network has 17 independent collections presented in Latin America, South Africa, Portugal, and Spain. Our virtual environment system is based on an open access approach, as you can see from the website in this slide. The first picture is the Cielo Brazil website, where you can find more than 300 Brazilian scientific journals and 400,000 articles published. The second picture is Cielo Books with more than 1,400 academic books in ebook format, where 61% are open access. The third picture is our open journal system to manage its quarterly journal. The fourth picture is our preprint website. Cielo has adopted PKP's preprint system as a scientific communication flow, citing, referencing, and sharing the research data and other content related to the articles in review, as well as promoting options and mechanisms for opening up the peer review process. Since 2020, we are using Dataverse application to create journal repository to manage the submission, review, and publication of data associated with published article or in the process of being published. Each Dataverse represented journal where the authors from the journal can deposit their data set. Each journal is responsible for its curatorship. How to preserve our website from Cielo open access environment. First, we thought about using the locks system to guarantee preservation. We started a partnership with Cariniana to integrate into Cariniana Locks network. To integrate with Locks network, it was necessary to use a plugin that was developed by Clocks a few years ago when we were associated with it. So we used the plugin for the Cielo Brazil website preservation, but to preserve another website like Data Cielo or Preprint Cielo, we had to think about another alternatives. To do so, we adopt the method of web archiving workflow to take a snapshot from the website. The web archiving flow consisting of producing web archive files with all digital assets from the website existing at the moment. And to read the web archive files, we resorted to the Open Wayback Machine project to index this file, as you can see in this slide. All created web archive file are organized and stored in data sets, as you can see here in this picture. They are identified by months and years. But how can we guarantee these digital files were preserved? This is another part of the data sets that you can see the file that we organize. To do so, we added Archimedica in the preservation workflow. We choose Archimedica because it's an open source software in compliance with OAIS model, where we can monitor and control the ingest and preservation of data. The workflow is pretty easy. After create the web archive files, we store them in a data set identified by month and year, as I mentioned earlier. Then we integrated the Dataverse with Archimedica, where we use the Dataverse as a data source, and each data set can be inserted to do the preservation process. In the end, Archimedica generates an archival package, as you can see in this image here. The archival package has to be stored in another local, geographically speaking. We integrated AWS S3 on Archimedica to store this archival package. AWS guarantees that this package will be stored in 3 different zones. The flow to preserve data set created by the journals users is the same as presented earlier. Now I will play a video explaining the Archimedica preservation flow. I'll go to put. So we have some challenge. Until now, we are doing the process manually. We have to automate the process. For now, it is to manage, but with many data sets, it will become impossible to continue doing so. So we have to automate this process. We are thinking about logs integration to store archival package, but the version that we are using is not possible. Maybe in logs version 2. We are testing mini-IO in distributed mode as alternative to AWS S3 when to preserve and the frequency. Archimedica preserve data set regardless of their state of mode. Doesn't matter if the data set is in draft mode or published. If we adopt only preserve and published data sets and the author continue chain data set, we won't be able to know for sure the preservation frequency. We are for this, maybe to solve this problem, we are testing dataset API to filter dataset published and modified to determine the frequency. This is the challenge that we have in this moment, and that's it. Thank you.
Thank you very much. That was very impressive to actually see, like everybody else is saying, it's nice to actually see Archimedica in a workflow and in a use case. So I'm sure you'll have lots of questions at the end of this session to discuss. Okay, our next presenter is Nick Weber from QDR. And Nick is going to be talking about human-in-the-loop preservation at QDR. And his presentation is in collaboration with Jim Meyer, Sebastian Karcher, and Seba Ostrowski. I think I pronounced that. Okay, thank you.
The Polish names are hard.
Thank you, thank you. Welcome and take it away.
Thanks. So thanks so much, everyone. I'm Nick Weber. I'm the technical director at QDR. And as Sonia mentioned, we have a team of technical developers, including Jim, Sebastian, and Seba. So I'm presenting on behalf of them. So let me talk sort of briefly here. I'm going to talk briefly about how we approach tool development for preservation at the Qualitative Data Repository, and in particular, how we rely on the packaging standard Bagit to accomplish distributed storage. So a little bit of background, the Qualitative Data Repository focuses on curating, publishing, and facilitating access to data that are produced using qualitative and mixed methods research techniques. And QDR was founded in 2014 with a continuing grant from the National Science Foundation, and we've been running a modified instance of Dataverse since 2017. And over that time, we've been pretty active in contributing to the code base at IQSS and hopefully doing some helpful things to push the Dataverse community towards reliable preservation. So QDR currently contains about 207 data projects spread across 6 different collections, or what Dataverses would call 6 different Dataverses. Those data are deposited in QDR include the kinds of things we would expect from qualitative or mixed methods research, things like archival documents, audio files of interviews, videos that are collected and analyzed from around the web. And QDR operates Dataverse using what we call, or what we can think of as, a mediated deposit model. So depositors initially propose a data project and then provide documentation and descriptive metadata or other forms of documentation. And then our curators at QDR work closely with depositors to ensure that the proposed data project has clearance from IRB or ethical boards, have proper privacy controls in place, or that we can actually host the privacy sensitive data. And really importantly, for scholars that are consulting archival documents and oftentimes collecting those from archives around the world, we have to do a lot of copyright certification in making sure that we can actually host and publish that copyrighted material for reuse. So this process of mediated deposit is really time intensive. It can be a long process from the initial proposal to the actual publication of data projects at QDR. So for example, right now we have about 31 projects that are in various stages of curation. They're being prepared for publication, some just a few days old and some months old, in which we're still negotiating around copyright and whether or not we can host different parts of the data collection. But this also means that preservation of deposited materials, like all repositories, is incredibly important to our customers, because the data that we're being given control over are highly unique, irreplaceable, and oftentimes, as I said before, privacy sensitive. So in addition to preservation, we have to focus a good deal of our time and our efforts on heightened security over access to different data collections based on a depositor's need. So QDR currently follows a number of best practices that have been alluded to and talked about in other presentations here nicely, so I won't go over those, but we follow some sort of best practices in creating standard submission information packages, archival information packages, and dissemination information packages so that we can run a compliant OAIS repository. One of the simple ways that we approach preservation of these different data packages that we have is through distributed storage, or sometimes maybe colloquially referred to as lots of copies keep stuff safe, or locks. So each deposit that is published at QDR is also duplicated and distributed across 3 storage environments. So we refer to these as our production environment, which is data files being stored on an AWS S3 bucket. We also have an offsite backup that is published to an infrastructure that we maintain at the Syracuse University Maxwell School. And then we also have what we call kind of a regional backup. So that is, if there's a disaster on the East Coast where our S3 buckets and Syracuse is located. We have something on the West Coast, which is in a Google Cloud, different cloud storage environments. This distributed data storage is sort of important for us to be able to provide guarantees to our depositors about the different places in which their data can be assured to have preservation backups. But it also requires us to sort of think closely about how we package that data and how we distribute it. So one of the ways that we've approached the duplication and distribution of data packages to these different environments is through a tool that Jim Myers has been at the forefront of developing and extending over the last period of 2 years, based on 2 specifications. So one is OAI ORE and the other is Bagit. So I'll focus most of my talk sort of on the idea of Bagit as opposed to OAI ORE. But for the sake of the talk, right, I'll say that OAI ORE is a way in which we can kind of easily crosswalk and capture metadata that is a part of a bag, or can be combined with a bag standard to distribute the storage. Okay, so Bagit is the other specification that we use to actually package up or bundle our data for this distributed storage. So we can think of a bag as sort of like a folder directory on a computer. It's essentially comprised of 3 elements. It's a bag declaration text file, which is kind of like a seal of authenticity. A text file, which is a text file manifest, which lists the files in the collection or in the bundle of the package. And a subdirectory, usually called something like data, which is what contains or what stores the digital content of objects that are to be preserved. So importantly, or sort of like the critical link in a bag, is that there's a manifest, and this manifest is machine readable for automated data ingest or data transfer. So when a bag or a package is created in one environment and sent to another, the receiving computer or the receiving environment analyzes the manifest and then runs checksums on the contents. And if the checksums match, then we think of the transfer as being successful. So a bag can also contain something that's a text file, which is called the baginfo.txt. And this contains a small amount of administrative data, such as the contact information for the collection owner, a brief description of the collection, etc. Users, or in this case, QDR, can include more metadata about the collection as they choose. This is kind of like a supplement. So the additional metadata can either reside in that text file, or it can be placed in the data directory. So I'm going to show a sort of simple example of how we use this option in the next slide. So on the left-hand side, you can see, and I'll also note if I'll make these slides available, and you can check out the example that I'm talking about here, which is really just a kind of canned example for the sake of demonstration. But on the left-hand side, we see what the bag actually contains. So it has an identifier, which is based on the digital object identifier that's minted when we publish a data collection. And then we see the 3 elements that I described previously: the baginfo.txt, the bag text itself, and then a manifest, which is based on the SHA-512 standard, which is guaranteeing that that thing is what it purports to be, right? That contains the checksum, which is validated when the bag is transferred between different computing environments. Okay, and so on the right-hand side, this is the optional bag info text that can be included. And this is really just some administrative metadata, which has, attributes and values. Importantly, though, I would note sort of at the ends of this the end of this bag info text, we have things like the size of the bag. We have things like the internal identifier or the date in which the bag was created. And so this is important as sort of just a cross-check or a cross-validation on the bag as it's distributed across different environments. Okay, so to kind of combine this, or to explain how this works in QDR, Each time a QDR data curator publishes a new collection, they can use the tool that Jim has designed to create the bag and the ORE map, or that is the package that we're going to create for archiving. And then they can choose a destination to send the package. In our case, we send the package to 2 locations in addition to the AWS S3, one to offsite to Syracuse and the other to a regional backup, which resides on the West Coast. So this is sort of the simple way in which we do that distributed storage, relying on standards like OERE and Bagit. This also, though, sort of has been extended, and I think in really exciting ways for the Dataverse community, achieve some interoperable preservation for the types of data collections that we all curate. So as part of this, one of the things that Jim and QDR, the Texas Digital Library, which I think is going to talk next, and the GDCC team have done is enable these packages to be retrieved and restored in different production environments. So this allows us to maybe pick up a data package that has been deposited somewhere else, easily implement it and put it into a new repository. So we can think about this as facilitating that sort of disaster management or disaster scenario in which all of the other remote storage locations go down. If we need to set up a new kind of temporary Dataverse or a new temporary repository, we can easily round trip that data from the initial point of publication to the remote storage to a new environment. And I should also say that this sort of builds on or extends some of the work that's also been done around the DV uploader tool, which I think is a really neat way in which we can retrieve bags and we can put them into different environments. And to also sort of close the loop, so to speak here, is one of our main goals at QDR, as I talked about.
Nick, 1 minute left, okay?
Yep. So one of the main goals that we have at QDR for our technical team is to reduce the manual work of curation and preservation. So offloading the creation and distribution of these valid bags is something that allows our curators to do at the point of publication, as I said before, but it also allows them to then spend more time with the data creators or the depositors, assure that the duplication meets community best standards, and then have confidence that the archived packages can be retrieved and restored in this scenario of disaster recovery. All of this, as I sort of had in text on previous slides, but didn't maybe mention, is already available in Dataverse, I think since version 4.11, but someone else can correct me if I'm wrong there. And importantly, I think the tool allows for endpoints to be configured so that any destination can serve as a backup. That can be cloud vendors like Google, such as we use, or even other Dataverses or other infrastructures. So this is a kind of brief mention of the things that I talked about and places to point you to see more discussion of that round tripping that I talked about. And one last plug that I'll just put in kind of briefly on some preservation tools that we've developed at QDR is called Web Archiver. This was developed by Sebastian Karcher and a couple of other individuals. It automates the deposit of web-based resources into collections that are specified by the repository at the Internet Archive. So you can also see that tool there. It's based on R. And that's it. Thanks.
Thank you very much. That was very interesting, Nick. We appreciate your presentation here today, and I'm sure we have a lot of questions. You can actually check in the chat for questions if you'd like to answer some. People have been putting questions in there, and we'll be sure to get them in the Q&A. So you can continue to put your questions in there, and we'll make sure to get them to them as we go. So our next speaker is Courtney Mumma from TDR, who's going to be speaking on preservation of the Texas Data Repository. Welcome, Courtney.
Hello, can you see my slides?
Yes, we can.
Awesome. Hello, howdy everybody. I'm very pleased to be joining you today from my home in San Antonio, Texas, known as Yanaguana by the Paella people, and on the traditional land of the Humanos Tonkawa and Tate Pilam Coahuiltecan. Very briefly, I'd like to tell you a bit about who we are. So I'm Courtney Muma. I'm the Deputy Director of the Texas Digital Library. Our collaborative consortium is based in Texas and rooted in higher education. The Texas Digital Library, or TDL, builds capacity among its membership for ensuring equitable access to and preservation of digital content of value to research, instruction, cultural heritage, and institutional memory. You'll notice that this mission is highly aligned with the Dataverse software and community. I also want to emphasize that we are rooted in higher ed, and higher ed is important to our identity, but we leave room for membership outside of this core group. Additionally, note that preservation of digital content of value to research, instruction, cultural heritage, and institutional memory is central to our mission. We are trying to capture the full scope of the content we provide access to and preserve. TDL has 27 member institutions, mostly academic libraries in Texas and one in Arizona, and also one public library and one community college now. We offer a suite of hosted services that provide technology infrastructure for scholarly communications and digital scholarship. You can see from the slide our different service offerings and the open source software or community-based solutions that we use for each service. Part of our strategic plan is to make sure that each of our services has a digital preservation pathway. We have accomplished that for our DSpace institutional repositories and our open journal system services already. But while the TDR Dataverse has robust backup protocols and the Dataverse core software has many digital preservation functions, data sets are not being stored according to digital preservation good practice. As you all know, digital preservation is a complex, moving target, which requires resources far beyond what most institutions can allocate on their own. TDL is the only Texas-based organization offering digital preservation consulting support and storage solutions anchored by archival and library expertise. We provide technical and community support, as well as individual consultations for our members who use our digital preservation service. This diagram describes how TDL's digital preservation storage works. You see here we have our own TDL hosted installation of DuraCloud, an open source software application suite led by Lyrasis. DuraCloud serves as the ingest point and the dashboard for users to manage any combination of storage options for their content. Currently, those options are Amazon S3 and Glacier, as well as Chronopolis, which is a non-commercial digital preservation storage option, geographically distributed and rooted in the cultural heritage community. So to align with our Texas Data Repository Roadmap and the TDL strategic plan, we started to prepare for digital preservation of TDR datasets in 2019. First, the TDR Steering Committee, who are liaisons and staff from our member libraries, developed preservation guidelines based on Dataverse, DuraCloud, and Chronopolis documentation and consultation. That documentation will be published to our TDR user documentation wiki, but for now it's in our Google Drive at a link which I will share with you in chat right now. Once their work was complete, Jim Myers contracted with us to apply the digital preservation process, which he had already developed and which you just heard about, for DuraCloud and originally the defunct Digital Preservation Network, or DPN, to the TDR. Using his work, we first attempted to move datasets into TDL's DuraCloud in December of 2020, with the intention to do ingest to Chronopolis twice annually. Unfortunately, we found moving single datasets, and there are over 1,000 of them, is not a feasible workflow for us, and the batch workarounds that we were trying didn't work. So we abandoned ship, and we will try again as a batch ingest after our upgrade later this month. Beyond the batching issues, there are several challenges we face in preserving TDR data. First, there is no disposition set for any of the research data. TDL promises at least 10 years in our agreements, but we don't yet have plans for large-scale purging of Dataverse datasets or of our Chronopolis storage. Next, digital preservation workflows will not apply to developing workflows for storing larger data sets at external computing sites. While TDL is happy to make the commitment for data that already complies with TDR size limitations, we can't promise the same for larger data sets. For this reason and others, digital preservation workflows complicate the core trust seal application process. As you have seen in presentations here and elsewhere over the last few years, it is risky to add software and service elements to core trust seal applications, especially in Dataverse installations, which are already distributed across a consortium like ours. Finally, there are no service guidelines yet for when institutions exceed their TDR space allocations of 2 terabytes per institution. Once we reach and exceed that threshold, TDL will likely have to move to a tiered membership model for larger allocations and would consider charging for digital preservation over a certain amount or allowing institutions to opt out of the digital preservation option. So that concludes my overview of our TDR digital preservation efforts at TDL, and I'm happy to answer questions at the end of the panel today. Thanks again for having me.
Thank you, Courtney, as usual, for presenting today. Love to see what you guys are doing over at TDR. So I'm sure it'll be a good use case for somebody going forward.
Thank you.
All right, and our final speaker is Deirdre Kermis, who is Systems and Security Technology Services at ASU Library, and she's going to be speaking about ASU Research Data Repository Backup Workflow. Thank you and welcome. Take it away.
Hello, can everybody hear me? Okay, I had issues with internet yesterday, so I'm going to give this a shot and hope that it works. If it doesn't, somebody yell at me and I'll just stop. Okay, hi Dataverse community. I'm Deirdre Kermis and I'm part of the technology team for the ASU Library Dataverse installation, or better called the Research Data Repository here at ASU Library. You guys hearing me okay? Just making sure.
Yes. Yes.
Okay. At ASU Library, our Dataverse installation has been running in production for about 8 months, so we're still in the midst of implementing optimal solutions for data preservation and integrity. Our first step was to meet the minimal requirement of keeping our data stored securely and across multiple locations and to make it sure it's accessible. So this presentation is describing our backup workflow that we have implemented mostly in AWS. We haven't really started working with exporting bags or further preservation at this point, although we have been successful in integrating Archimedica. We have an installation of archive space too, so that may be our next endeavor. Or we'll be working with TDL. We appreciate any input from the community about improvements that we can make in this workflow. So,
okay, Deirdre, we did lose you. I don't know if you can hear me, but what I'm going to do is share your presentation on your behalf. If that is okay, I'm going to jump in and do that.
Please do. So sorry.
Oh, no problem at all. So let me just make sure that I can actually do this. And here we go. And
hello, Dataverse community. My name is Deirdre Kermis, and I'm part of the technology team for the ASU Library Dataverse, which we call the Research Data Repository here at ASU Library. At ASU Library, our Dataverse installation has been running in production for about 8 months, so we are still in the midst of implementing optimal solutions for data preservation and integrity. Our first step was to meet the minimal requirement of keeping our data stored securely and across multiple locations, and to make sure it is accessible. In this presentation, I will describe the backup workflow that we have implemented after literally months of testing backup solutions, looking at cost, and considering disaster recovery scenarios. I will talk briefly about each backup location as they each have separate configurations. After much research and consideration, we decided to utilize AWS S3 services for storing our data, which included the ability to utilize lifecycle and replication roles. Also, by utilizing multiple accounts in AWS, we can separate copies of our data by location or AWS regions. We also began using Wasabi Cloud Storage to provide a completely external copy of our data. So in our backup solution, we have S3 buckets in our AWS production account, duplicate buckets in our AWS disaster recovery account, and S3 buckets in our Wasabi cloud storage account. We replicate from AWS prod to DR using AWS replication. Then we copy the files from DR to Wasabi using a tool called Archimedica, as well as AWS CLI and pgdump to export the database. In all three accounts, we have a bucket designated for user files, files uploaded to Dataverse datasets, and a bucket designated for database exports of the Postgres database. The exports of the database run every night. The buckets in the different AWS accounts reside in different AWS regions across the country. The Wasabi data center used is in Texas. This is a diagram to show the overall flow of data between accounts and of the rules in place for moving the data. We start with the files in the S3 production account written to the standard storage class. Those files are transitioned into intelligent tiering after 1 day because it's cheaper, and then replicate to the DR account immediately. Once they appear in the DR account, we have a script that copies the files to Wasabi utilizing a tool called Archimedica. After the copy to Wasabi, the files are then transitioned to the Glacier storage class, which is much less expensive than standard class. The last step of this is that any previous versions of the files are transitioned to Glacier. We'll discuss this a little more in a few slides. This is the flow for the database export bucket, which is the same other than we also have a rule in place to expire and delete the files after 365 days. We didn't feel a need to keep database backup files forever. We will look at the rules configured for each account in a little more detail. First, the AWS production account. In our production account, we have a lifecycle rule configured which transitions the files to intelligent tiering after 1 day. It's important to also transition previous versions of files as well. Otherwise, you will have a version in standard class and a version in intelligent tiering. We also enable the setting to delete expired delete markers when all versions of the files are deleted. For the database export bucket in AWS prod, we also added a rule to delete files after 365 days. So we will only keep these files for a year. The last rule that we needed was the rule to allow the files to be replicated to the disaster recovery account. The files are replicated immediately after uploading, and they go directly to the DR account into the standard storage class. It is important to make sure that you have a policy for the user or role that allows the change of ownership on these files and also that allows for file replication. Next, we can look at the rules configured on the DR account. On the user files bucket in the DR account, we transitioned the files to the standard storage class so that we could copy them to Wasabi, as files cannot be copied after moving to Glacier. We added a lifecycle rule to transition previous versions of files after 1 day. We handle the transition of the current version using a script. We will discuss this more, but note that anytime a file changes storage class, it creates a new version. The database export buckets are configured the same with a rule to transition previous versions to Glacier after 1 day. We handle the transition of current version using a script. Database files also have a rule to delete the files after a year. Last, we will talk about the copy of files to Wasabi cloud storage. Wasabi backup is a little more complicated as we can't utilize built-in replication services that exist in AWS. On our Dataverse EC2 instance, we set up credentials files for both our clone, which is a config file, and AWS, which is the .aws credentials file, since we are using both tools for different functions. They both look basically the same, and we have a config for each one of the locations in each one of those files. We have 2 scripts that run nightly. The first script uses pgdump to create a database export of the database. It then copies that export file to the AWS prod S3 database bucket. The second script copies the AWS DR user file bucket and the AWS DR database bucket to corresponding Wasabi buckets. It then copies the current version of the files on the DR bucket to the Glacier storage class. As we were configuring this, we did quite a bit of testing and looking through the files in the S3 buckets to see what was happening. A few issues arose that caused us to make adjustments to our configuration. So it turns out that there's a little checkbox in the replication rule settings that is quite important. The change object ownership to destination bucket owner box is not checked by default. But if you want to be able to do anything with the files, once they're copied to the second account, you need to check it. We found that the files were replicating okay to the DR account, but the DR account didn't have permission to copy them to Wasabi. It wasn't enough to just check the box, though. We had to copy all of the files again while changing the storage class back to standard, which allowed them to replicate again. We also had to add a directive into the bucket policy into the role that allowed the change of ownership. And once the files were recopied, we deleted the previous versions. Speaking of previous versions, we also found that we needed to have rules in place to manage these previous versions of files. AWS keeps versions of deleted files and files transitioned to another storage class. In addition, files deleted in Dataverse are not automatically deleted in AWS. We created specific rules in our lifecycle management for the buckets to make sure that previous versions are deleted or transitioned to the lowest cost storage class. Our team is relatively new to the Dataverse community, but we've already benefited from an awesome amount of help and advice from other organizations. We are excited to collaborate with other members and would love to give back and help out where possible. Thank you so much for listening.
Thank you. We did get it to work, so no problems there. Great presentation as expected, so thank you. And I believe that ends the presentation portion. Let me just make sure I'm not missing anybody in here today. Okay, so we have time for Q&A. So I'm going to open up the floor for that. And if your questions have not been answered in the chat, go ahead and feel free to unmute yourself and ask your question. There's also conversations taking place in the notes document. So anybody who, let's see what's going on in the notes question section. Okay, so most of the questions that have been going into the notes are being answered, but I do see some. I'm going to share my screen briefly so we can take a look at the questions that are coming into the notes. So give me 1 second. Okay, so okay, I don't see any actually open questions that are not being answered here. But I do see that they're in the notes document that people have put links to a number of related contents to the talk today. So people might be interested in getting into the notes document to access that information. And otherwise, I am going to stop sharing it and then we can have an actual discussion. So please go ahead
Sonia,
if you have questions. Yes.
We have one question on the chat. Could you please take a look?
Okay. Backup of database and user data. Is it synchronized by Dataverse or something is needed extra? Who would like to take that question on?
I can try and answer. Basically, the backup of the database and the S3 storage for the files is stuff that's been set up kind of like Deidre was talking about, right? It's sort of outside of Dataverse, sort of your normal backup kinds of mechanisms that are, you know, just the normal things you do. The Bagit stuff for going into long-term storage, that's set up as a Dataverse workflow. So when somebody publishes, it automatically triggers creating that bag in the ORI map file and sending it off to Google and everything. So that one's all automated through Dataverse mechanisms, and that's the same thing that TDL is doing, just with a different switch to send it instead of to Google to send it off through the DuraSpace interface to Chronopolis.
Okay, thank you. And another question from Dorothea. What would be the largest data file and file size that Archimedica can handle?
I can maybe speak to that a little bit. Archimedica essentially will process as much data as you kind of give it power to do. So the more CPUs, RAM, memory, and processing space that you provision to Archimedica, the more data that you can process. They have a general guideline, which is that the amount of disk space to actually be used for processing should be 3 to 4 times the size of the actual data set that you are processing. So if you are trying to process something that's 1 gigabyte, you need at least 4 gigabytes of sort of scratch space. And there are different ways that Archimedica is provisioned by different, host service providers, people installing it. For example, CERN uses Archimedica for very, very large data sets. And they've provisioned it with an insane amount of computing power. So it can scale really well. It does have a limit in terms of number of files. I believe, unless this has changed in the past couple of years, that it's 10,000 files per package. That's sort of like a hard upper limit. But again, there's possibly ways around that as well. It just depends on the amount of provisioning that you have available.
Another thing that we have to worry about is the configuration of your web server, because you have some parameters like in the Nginx or Apache that you have to set to accept the upload. So I think our Archimedica don't have limitation, but in your web server you can have. That's another thing that you have to worry about it.
Okay. And Jim has offered some insight into the chat as well on the question. And we have some preservation policies for the Harvard Dataverse repository that's posted into the chat. Any other questions? Do the presenters want to talk about anything else? I would be interested, again, I had posted, I would be interested in having a document comparing all these backup processes and tools to see, just the strengths and weaknesses in them, to see, where the benefits are and where the challenges are, just in one simple view.
I see I have a question from Grant directed towards me. Sonia, can I take that?
Yes, please.
So Grant's question is, what were the technical issues with batch uploading data sets to DuraCloud? Jim can talk more about it in a more technical sense, but we tried, basically, my sysadmin and Jim in Slack were furiously trying to do workarounds, command line workarounds, so that we could do batch instead of singular data sets exports, but none of it worked, and it just ended up taking, we spent about 2.5 days on it, and for us, we have a staff of 8 and only 2 sysadmins and 2 developers in that, so 2.5 days is a long time. So we had to abandon ship and kind of reschedule it for this next update. So maybe Jim can add a little bit about the technical issues, but we did try about 3 different methods.
Yeah, I think I had a hard time getting enough info to I don't think we fully debugged that, but one of the things we tried was putting in a batch API that essentially just looks through the list of data sets and runs what's already running to do each data set to do the bag export. And there may be some simple bug in there, but I guess that was one of the things that didn't work. And finding out exactly which line of code we haven't done yet, but it's really just replicating this. It's just going through the loop internally in Dataverse. Using a few threads to do that. The other thing that was interesting with TDL was just that because they're doing batch stuff, the way we went into DuraSpace Chronopolis to begin with was that each data set was its own space, and some of that was talked through with DuraCloud and Chronopolis early on about what's the right level of granularity for retrieval and storage, right? If you want to get things back, would you be requesting a single data set? In which case, even though they're small, we want to have them as an individual space. But for them, that means that if you do 1,000 data sets, you have to go press the button on 1,000 spaces. And so we haven't gone through and tried to figure out, what it makes more sense to be able to name those things differently and aggregate things into spaces when you send them off through DuraCloud or not. But something like that might help automate for things where you want to do batch in larger numbers.
Thanks, that's very helpful. We're using DuraCloud at Scholars Portal in sort of a development context right now. It hasn't been fully integrated, but it's helpful to know some of the limitations there. Thanks.
Right. And Danny Brooke has a question.
Yeah, thanks. Thanks, Sonia. Thanks to all the presenters. So I guess kind of a two-part question. I mean, I'm by no means a preservation expert, but like it seems to me that the Bagit workflow is more of a push and Archimedica is more of like a pull from Dataverse. If that's accurate, what's the driver of the decision about which one to use? Is it based on the infrastructure that you already have in place, or is there one better than the other? I guess I said I had a two-part question, but I guess I'll leave that question there and then maybe ask a follow-up question.
I mean, my answer would be no, there's no preference. I think that, the decision for the Bagit stuff was there's no application sitting on the other side with a GUI to press the pull button on. So we did it as push, right? And again, TDL has sort of tweaked that because they're actually, they call the API directly. So they're in essence doing a pull through the API as opposed to pushing through the workflow. So, that I don't think there was a big concern there in either direction. In terms of the comparison document kind of discussion that's going on there too, I think that document's a good idea. The basic thing I see is, Archimedica is just, completely full featured and does all sorts of the microservices and things. And the Bagit stuff, we're sort of relying on the fact that like when you publish in Dataverse, the checksums are checked and things. So there are some of those kind of microservice-y things that are already done, but not a lot. And then the Bagit, is more of the, quickly produce an archival information package without all of the detailed provenance and stuff that Archimedica can do. So, in some sense, they're apples and oranges that way. And I think at 2020, we talked about, would it make more sense for Archimedica to pick up the bag from Dataverse as a starting point, since that gives you the metadata and data together, or would a bag structure be a good thing to spit out the other end? And nothing that I'm aware of has happened there, but I think those are, that might be a better way to think about these two things, is that they're not really competition. They're sort of really solving, either different problems or the same problem at different levels of sophistication.
Okay. Do you have another question to that, Danny, or are you all set?
Yeah, I guess I'll just ask the other question. Again, not a preservation expert, but I understand that like an important part is like virus scan, for example. We might want to build this into the Dataverse software itself because it's important for other reasons. But like where do y'all think the best place for that in kind of the workflow is? Is it, upon upload, and does like Archimedica, for example, have this as part of the feature set?
I'll just make a quick comment again that I think things like, virus checking, I think there would be a lot of value to doing that early, right? If somebody's uploading and you could tell them then, they can give you a virus-free copy. Whereas if it's waiting in Dataverse for a while and then published and then gets off to Archimedica, right, that you've got a much harder time to try and get a new copy from the original author. So I think some of these preservation steps, it would be interesting to pull forward.
Cool, thanks.
Okay, and we have a question from Philip Durbin.
Yeah, hi, this is more of a comment and an invitation than a question, but as I was looking at the chat, I'm seeing questions about backups, which are highly related to preservation. And I'm going to link here to the page we have in the Dataverse guides about backups. And it's quite short. It just basically says you should do backups. And then it mentions the script that we use at Harvard to push or pull files to a specific on-campus resource via rsync, SSH. But looking at this and how short it is in terms of like how much guidance we're giving, it makes me think about how for other features like homepage customization, we had Sherry Lake give a great poster about what she's done at UVA. And maybe we could do a similar trick with this backups page, where if the speakers here are interested, they could list their slides from this presentation, from this session on that page and just say, you know, here's one approach, here's another approach. Just a thought that we could sort of get more information out to the community of what different installations are doing. That's it, thanks.
Okay. Anybody want to add some comments to that? The panelists? Okay, then we can go on to any other questions or comments from the group. You can raise your hand or jump in. We have 3 more minutes.
I'll add something.
Go right ahead.
Because I love to fill silences. So I just want to say, kind of call back to something I mentioned very briefly in my slides, which is that the curation of research data is also a major issue in digital preservation of that data. Because once it's preserved, then what is my question? Because a lot of the data sets don't need to be kept forever. And so right now, in most of these solutions, it sounds like we're all preserving them and they're there, but the then what question is still kind of outstanding. And also the cost, which obviously comes up quite frequently, but just thought it was worth bringing up that importance of that curation discussion with regard to digital preservation too.
Sherry has her hand up.
Hi, and thank you, Courtney. That is a great segue. I know it's a few more minutes for this segment, but the last breakout session that's after this one is on curation workflows, which, as you said, is a great part of the planning up front. It's sort of multi-purpose for reuse currently, but also it can help in preservation. So thanks for that.
Kaylin?
Yeah, I'll add in also with Courtney mentioned, one of my big questions in here is sort of like, which data do we preserve in this way? And then who pays for it, right? And I think that's, the technical challenges are really interesting and compelling and necessary, but there's this entire kind of administrative policy component to it that is really almost harder, I think, because you've got way more stakeholders who have different opinions, different communities colliding over this. And then there's money involved, right? Because someone does have to agree to pay for this incredibly expensive service. And so how do you do that? And, for us, we've got this, the hybrid model where you have managed collections where there may be, there's an active team, maybe a journal or something, or institute that's stewarding the data. But then you've also just have folks who deposit it, individual researchers who are kind of self-serve. So what do you do, right? How do you appraise things in that way? So I think that is a really big question. And I don't think that there's necessarily, we don't have an answer yet. I think there are answers and categories of answers that will depend on your funding and how, right, your funding and what kinds of appraisal decisions get made about what should be kept for how long. But then, of course, there's the user part to it, which is how do you communicate those decisions and so forth to your user community so that they understand the expectations about, these kinds of decisions. And I don't have an answer there either, just lots of, I think, conversation around that, and yeah, just more conversation I think is needed in that regard. So thanks, Courtney, for bringing that one up. Yeah.
So I'd like Kaylin, Courtney, and Sherry to keep tab on that question of appraisal for the community meeting next year, because I do believe it needs a larger discussion. Where I've had contracts that said that data had to actually be destroyed, not returned, but destroyed. I mean, first of all, it was heartbreaking to destroy it, but then we actually did it. But otherwise, going through your collection and determining what has value and what doesn't have value without, community policies or community understanding, and I don't even know where to begin with that. I mean, we could use the Dataverse tool, the metrics, right? Has it been used in the past 5 years? Has it been used in the past 10 years? If it hasn't been used, there's one, variable that we could use, right? To determine what gets kept and what doesn't. I keep thinking about the collections growing in the Harvard Dataverse. And I'd like to go back and see how those first collections are being used, if at all, given how much content there is. So I think that's a good question for a good group breakout session for next year's community meeting.
Yes, I just want to say my impression of this session. I was very impressed. So the son of ways on digital preservation as far as our community today. I guess it's the first time that kind of meeting that we have around the preservation issue. And I'm really glad to hear that and for sharing all your experience.
Thank you, guys. It is 11:17 and we have a next, again, as Sherry mentioned, we have a closing or another session at 11:30 on curation workflows that Sherry and I will be chairing. So we look forward to having you guys participate there as well. Thank you to all the panelists today. This was really informative, enjoyed the discussion, and I hope that we can make some of the requests that we have in our community notes into fruition here, have some documents and links and more interaction on this. Thank you, guys.